how do the economics of biogas compare to other traditional sources? I mean, how could we answer that? I've got a figure in my mind. I heard that you get around a 40 to 45% stream of CO2 from biogas, but I guess it varies. So what's the economics behind that?
Yeah, hi Maura. They're very similar actually, depending on which source. You're talking about a 45% CO2 stream, but if they're in the biogas, but if they're injecting biogas if they're injecting methane into the natural gas grid, which is the plants that we focus on, they're already usually through a membrane process, already separating the methane and the CO2. So the CO2 purity coming out of that membrane is somewhere in the 97, 98%, sometimes higher range. So we're starting with a raw gas stream that's very similar to what you'd start out with in a large ammonia plant or a bioethanol plant or ethylene oxide plant. So we're starting at the same place in those instances. And as other than what I mentioned earlier, the heavy weight of the capital, so in your economy of scale, the operating costs are very similar. You'd be surprised. Spec power maybe a little bit higher, 10, maybe 15% higher on the power usage, because you just can't get that optimization that you're looking for. But the rest of the costs are similar. I'll give you a really good example of how heavy that lack of economy of scale is. Typical analytic systems for certifying your product to the high food and beverage grade are very large, very complex and expensive systems. They can cost anywhere from, if we talk in euros, from 250 to 350,000 euros per installation. And whether your plant is producing 10,000 tons per year of product or 150,000 tons per year product, it's exactly the same system. You don't need any more or any less. It's identical. So what we have on our plants in the UK is exactly the same system that the large ammonia plants in Europe are using to certify their product. Yet our amortization is 10 times more for that system. So the cost of us being able to do that is extremely high. And that's where it really gets difficult. As Alfonso said, you really need to look at the larger plants. You can't be focusing on the ones that are down in the 4,000 or 5,000 tons per year. You can, but all the stars have to be aligned to make that work economically for you. And it becomes very, very difficult economically to make, to get a solid return. That being said, if we do get into these big supply and demand challenges, as I mentioned in my talk, you can expect the price of CO2 would increase in those instances, and then these sources will all of a sudden, some of the smaller sources will become more economically viable than they are right now. But you can make a case with the large sources, obviously depending on your price of CO2 in the market, and in North America, that market price is lower than it is over in Europe. And so it'd be a little tougher of a economic challenge in the US than it would be in Europe. Can be done.